In this competition, two design engineers will create a real-world system power supply. On the left, we have Joe, who will follow the traditional steps to design his system. On the right, we have Jeff, who will use Texas Instruments' WEBENCH FPGA Power Architect online design tool. We'll see how much time they take and compare their designs at the end of this video. Let's take a look at the real-world power supply design problem. The design consists of two data processing FPGAs, a precision signal path, an Ethernet control port, a temp sensor, DDR2 SD-RAM, and passive elements as seen in the list. To meet the overall project requirements, the complete power supply needs to stay within these boundaries for size, efficiency, and budgetary BOM cost. First off, both Jeff and Joe enter the power demands of the two FPGA chips. Joe takes quite a bit of time to build and paste FPGA loads to a master spreadsheet. Jeff has launched FPGA Power Architect, and he takes just a few minutes to select the FPGAs and update the default supply values in his FPGA Power Architect template. Now both designers need to add in the power budgets for the rest of the ICs. Joe takes several minutes to add the non-FPGA loads into his spreadsheet. Jeff takes about half that time to add the same loads using Power Architect. Now Joe takes quite a while to check the various rail dependencies for each FPGA. Joe needs to carefully examine the notes in each FPGA manual and make sure he finds all of the hidden requirements and limitations and understand how they affect his design options. Joe has to manually figure for considerations like power rail soft start guidelines, filters, and other restrictions such as sharing any filtered rails. Jeff has all of that automatically identified for him and presented to him in the WEBENCH tool. So now, the designers need to figure out what power supplies are needed to power the loads and how they will be hooked up to the input source. Joe takes a good part of an hour to estimate all of the power supply requirements in his spreadsheet, then works out a strategy to either combine or isolate loads into different power supplies. Finally, he comes up with a power tree architecture that he thinks he can use. Jeff uses FPGA Power Architect to calculate a wide range of supply architectures in seconds that he can tune for size, efficiency, and total BOM cost. The visualizer interface in WEBENCH presents a graphical overview of many supply architectures. With a turn of the optimizer knob, Jeff can fine-tune his design for efficiency, footprint, and the total BOM cost. So now it's on to creating the designs for the individual rails. Joe starts into the task with some design tools and his own notes and calculations. This is a long process. It may take Joe 2 days or more. Joe starts into this design creation process armed with his approved vendor list, various circuit calculations from datasheets, and uses the internet to search for the right parts. This research can take hours for Joe to accomplish. For Jeff, WEBENCH already includes more than 21,000 components from over 110 manufacturers, with price and availability updated hourly over the internet. So now we need to confirm the price and availability of the many components that we need for the design. Joe will head to the internet and check price and availability while keeping track separately of how close he is to going over budget, how many components, and which vendors are on his approved list. Again, Joe may take hours to accomplish this, but in just seconds, Jeff already has current BOM cost and can see how he can trade BOM cost for efficiency, footprint, vendor, and many other parameters. So now we've reached a finished design set, and Joe may take at least a couple of hours to compile all of his designs into a project documentation package. Jeff, on the other hand, presses the Print Project button to get a detailed project report for his documentation. The report includes a project summary, complete bill of materials, and schematics. Jeff can even send his design electronically to the layout team, purchasing, and other colleagues so they can incorporate this power supply system into the larger project. And just when you think the design project is complete, you get a surprise call from purchasing, telling you that one of your selected vendors is no longer an approved supplier.
What?
So Joe is sent back to the drawing board as he spends hours looking up his designs, determining which are affected, and then reworking the design, and then updating his system summaries. But all Jeff has to do with the WEBENCH tool is pull up his design, swap out the vendor, rerun his project and designs, in really just about 5 minutes, he can print out a new report and resend the project to layout. And Joe isn't done just yet. He still needs to check availability on the new part and make sure he's still within his budget. There's another half hour at least. But Jeff is already done. Hours ago. So things are wrapped up. The design is complete. After more than a week's worth of Joe's time, he has a design that is functional, but not optimized for the best power dissipation. He hopes that it will fit within the tiny space they gave him and not have any thermal issues. He's not even sure if he's totally within specs or under budget. Jeff, however, using WEBENCH FPGA Power Architect, has spent about 90 minutes to complete and share his design project, and he knows it's under budget, the parts are available, they meet board space requirements, and they have optimal efficiency. And the winner is Jeff and WEBENCH FPGA Power Architect. With a time savings of 38-1, a fully tuned and optimized power supply design, up-to-the-minute supplier pricing and availability, and complete design documentation, WEBENCH FPGA Power Architect beats the traditional design process every time. See for yourself. Go to webench.com and click on the FPGA tab in the WEBENCH panel.